Welcome to our presentation today on quality testing and testing tools as part of our SIGTalk series with Vivid. So in 2018, we've launched SIGTalk for the Vivid community, and we're rotating through a bunch of different topics on tips and tricks, proven practices, testing tips, and the such. And if any of you are interested in being a speaker, we have a survey available that you can fill out and be part of, just like Scott, who's going to be presenting with us today, and anyone else. We hope you find this a valuable presentation series as we're bringing real-life experience from individuals such as yourselves and bringing them to the community to speak about various testing components. Today I am your host and actually one of the presenters. I am on the board of directors as the education chair. I've been in testing for about 11 or 12 years now, focusing on test automation for the past 9+, and also juggling quite a bit of performance testing as well. I'm brought today with me Scott Moore, who's got over 25 years of experience in various platforms and technologies, and he's worked with some of the largest application infrastructures in the world. He's implemented performance engineering services for global integration vendors, leading insurance companies, large healthcare organizations, and major financial institutions. He founded Load Tester Incorporated in 2004, and in 2015 started up Scott Moore Consulting. Lately, he has co-founded Transact IQ, and it's a company that's focused on simulation, scalability, and security in the cloud, and Internet of Things, which he comes to talk to us today about. We look forward to hearing from Scott. Some quick housekeeping before we do get a chance to hear from Scott. This is being presented through My Webinar Place. If at any point in time you want to expand the presentation mode, in the upper corner there's a little rectangle box. If you click it, it should blow up the presentation screen for yourselves. In fact, we have some demo videos today that we're going to be going through, and I would actually encourage you to blow that up. On the side panel, you'll see a Q&A box where at any point in time you can ask questions for myself or for Scott. Or if you actually have any problems with the platform itself, feel free to ask. We will be answering questions towards the end of the session, or if there's ones we can answer in line, feel free. If you need to choose a particular language to ask questions in, you can also do that as well through the sidebar itself. As part of SIGTalk, we are using a hashtag of Vivid SIGTalk that we will be taking questions from as well. And we encourage you for any SIGTalk testing. Maybe it's after this presentation, you're all jazzed up about Scott's presentation on IoT or something that we said. Definitely use this tag so we can keep promoting these SIGTalks. So like I said, this is an ongoing session that we're going to be doing throughout this year and hopefully moving forward as well. So about all that housekeeping done, I'd like to turn over to Scott. Scott's going to talk to us about performance testing, the Internet of Things. So Scott, thanks for joining us today, and let's roll.
Thank you, Chris. It's always an honor to be able to talk to the Vivid crowd, and I am happy to be here today to talk about the Internet of Things. I am part of Transact IQ now. I am the Chief Technology Officer there, but that is a name change. Some of you may have remembered us as Endpoint IoT. So while the Internet of Things is a core thing that's important to us, we're also expanding into blockchain, cloud migrations, some specific security solutions and things of that nature. But Internet of Things is still really front and center for us. And so today I'm going to be talking about how would we performance test the Internet of Things from the perspective of somebody, and I feel like probably many of you have the same background as me, where you've been doing performance testing or you've experienced performance testing in the enterprise space. So web legacy apps, Citrix-based applications. So you're used to that kind of performance testing, and now you're hearing more and more about Internet of Things, and you're thinking, how do I apply the knowledge I already have to an Internet of Things platform? What's the same and what's different? And in the amount of time that I have to try to condense this down for you, I'm going to cover a couple of protocols called MQTT and COAP, and we'll dive a little bit into the weeds about that. And I'm going to actually show you what it would look like using a tool that we're familiar with, which is LoadRunner, to do some of this testing, at least from the scripting perspective. And I'll share some of the things that we've learned at Transact IQ for best practices. One of the things that I put about me here is that I'm a SEAL, a software engineer across the life cycle. And what that really means is I think about performance throughout an entire life cycle, but I have a very limited scope, so very wide range of interest in development, test, and production. But I'm not just a performance tester, which means I should be able to look at something that you're dealing with where you're struggling with performance, and I may be able to solve your problem without ever running a single test. And that's the kind of approach that you need to think about when you start thinking about Internet of Things, because it will require you to think outside the box. And we'll see this as we kind of dive into this. I would encourage you to use the button that expands your screen to full size, because some of these pictures I'm going to show you, you want to see the bigger picture. And as we go through the demo, you'll be able to read it a lot better. So let's just dive right into what an IoT architecture typically looks like. And from this screen that I'm showing now, this slide, look from the right to the left. On the right-hand side, we have the world as we know it. Could be inside, outside, and we're going to have these things that are inside the world: temperature gauges, pressure gauges, speed changes if you're inside a moving vehicle. So these sensors are going to be anywhere and everywhere, and they're going to react to certain changes, receive data, and transmit data. But they're not going to do it in the same way that a traditional website might take information from a form field entry and submit that to a traditional database. But on the left-hand side, we have the network itself, which could be Ethernet, could be Wi-Fi, could be something else, all the way back to the cloud. That could be your data center with traditional web servers, traditional databases, or it could be Amazon, Azure, or Google Compute platform. So the left-hand side is more of what the traditional enterprise testers are familiar with. Right-hand side is kind of what we're trying to figure out, what is that stuff, right? So that's kind of where we're going to go with this, and I'll try to make the transition. And this is a slide where you really definitely need to blow it up, because at the very bottom of this vector is the sensor itself that we were talking about. So this could be, say, a temperature reader that is outside of your house or your apartment. And when a temperature changes outside, it sends that change somewhere. Now, that could be, depending on the location, it could be a Wi-Fi router in your house. It could be sending something, let's say you're sending an Alexa call to Alexa for home automation. But how it gets to the back end or the cloud that we know about, that's really based upon the IoT platform that you're choosing. That sensor is going to transmit over some type of a wireless protocol, but it may not be Wi-Fi. It may not be something that is even in the mobile space. Like it could be 3G, 4G, LTE. It could be through Verizon. There could be some kind of a connection like that to a cellular tower. But the wireless protocol could also be dependent upon power requirements. It could be dependent on length of distance between the sensor and wherever it needs to transmit that information. And that place that it's going to send it to is, we would call that a gateway. Those gateways can just receive the data and retransmit it back up to a backend server. They may have a smart gateway with some kind of programming logic that makes some level of business decisions. But when we talk about how it transmits that data, there's two types of thought processes around protocols. A physical protocol, so we're replacing Ethernet cables with a wireless technology. Why wouldn't we use Wi-Fi? Well, you could, but some of the wireless technologies are a little more power hungry than we would want. So we have to think of transmission rates and what those power requirements are. So when you see words like polling, where it has to keep checking a device, you have to start thinking about battery drain, because everything has to be powered, even those sensors. So if you're metering something like a smart meter, you don't want to have to send technicians out every 6 months or a year to replace a battery, because that's going to make the deployment very, very expensive. I think it's an average of $300 to $500 just to replace each individual battery. When you have thousands of sensors over a smart city, even millions, battery life is very important. You want something that's going to last 5 to 7 years typically if you can. So we don't want the batteries to drain. So we have to think about that wireless transmission in terms of how long can the battery last and keep transmitting, but also the distance between it. Older versions of Bluetooth may be measured in feet. New versions of Bluetooth may be measured in yards. LoRaWAN, you may get miles for line of sight. So the distance traveled and how constrained the network are all have to do with that quote-unquote physical transport layer. But there's also that layer that comes after that, which is the data transport layer. So this is where, as a tester or an engineer, you really need to be familiar with how protocols like TCP/IP work and what sits on top of those protocols. So we would think of TCP/IP when we talk about TCP transport and the UDP, the datagrams, how TCP works and UDP works when it's talking back and forth to servers. And then what sits on top of that? Protocols like FTP, HTTP, things that we're used to. So we are going to have to consider replacements for HTTP because of the same constraints that we're dealing with these small sensors, small payloads, and things of that nature. As you get further up in this diagram, closer to the top is where you start getting it transmitted from these HTTP replacements into what we know, HTTP through a REST call, some type of API that eventually gets it up into a web server, into a traditional database server where it can provide graphs, metrics with traditional based cloud deployed web applications. So I hope I didn't bring you too deep in there, but we have to spend some time in protocols when you're talking about IoT, because that's really the secret sauce that makes this stuff run. And this is just a slide showing you a little more than half a dozen of the protocols that we see most out in the market right now. MQTT and COAP being probably the most popular. And it talks about here who the sponsors are, how it responds appropriately to highly constrained networks, what the security model is. So when we start talking about the transport mechanism, when we get down to the TCP/IP layer, we're concerned with, is it TCP based, where we need acknowledgments back to have a communication between the sensor and the back end, or is it UDP? So we're sending out these datagrams, and much like streaming technology, we send out requests, we blast them out like a shotgun. We may not get an acknowledgement back, but it's not necessarily required. So there's that model, and then there's also the messaging model. Traditionally, HTTP is a request and response. I request a web page and make a GET, I get a response back, or I fill out a form on a web page and post a submission, and I get a response back from the server. But there's also the publish and subscribe method, which is shown in a couple of slides later. I'm going to show you the publish and subscribe method, but it's different. We'll show you how they're different. I wish that I could go through every one of these protocols with you, but because we're limited to time, we're going to dive into MQTT and COAP next. The challenges that we see right now, because of the last two slides that I have shown you, you can imagine there is still sort of a Wild West feel out there with regards to IoT. We don't see a whole lot of standards that have fully emerged yet. And so the biggest problem is making everything talk and making everything where it's interoperable. We also have to consider that we have these new wireless protocols that we have to deal with. So how do we, in a pristine lab environment, simulate real-world conditions with regards to the network. Are we going to have to get physical sensors? If we're doing a performance test, are we going to have to get thousands of real sensors? Can we mimic those sensors? Are we just concerned with the calls, or do we care about the embedded system that might be inside of that sensor? So the goal is, how do we still see the end-to-end performance responses and be able to validate those responses? That's really where we're trying to help the market figure out how to get there. So usually the early adopters are going to be your telcos, your Verizons, your Sprints, because they're going to be rolling out these services to their cellular towers. If not already in some other countries in the U.S., it's coming very, very soon. And it's more of a firmware upgrade at the tower, so it's not like they have to send a lot of technicians out there to make this happen. So you will be hearing about this more as we move from, say, 4G LTE today on Verizon, say, to the 5G network, which is even going to be, up to, I've heard, gigabit speeds on your mobile devices. So think of it in this way. When we went from computers in the home or office to a mobile community where I'm taking this smaller version of a computer out into the field with me, it's a whole different network paradigm that happens. So now I not only have to worry about a connected network on a LAN that might be an Ethernet cable or Wi-Fi with higher speeds, but now I'm taking this mobile device and I'm way out in the country or rural area, and I'm connected to a very poor 3G network connection that has slowed my app down, and I have to think about that as a developer, how that user is going to be affected by that experience. So when I talk about recreating real world and the impact of the network, that can't be overstated. So let's talk about MQTT and COAP, and we'll get into details. There's an open question about how MQTT is different from HTTP. I'm glad that you asked that question, because we're going to answer that right now. MQTT was developed by a couple of guys from IBM who had to develop a solution to monitor an oil pipeline. So you can think of a sensor being put so many feet or yards in distance along a pipeline out in the middle of a desert somewhere. Those sensors are going to have to make calls or pings to let it know, let the application know that it's available, that section of pipeline is still there, it hasn't been cut, there's no problems. It's going to talk to some type of routing gateway. In this particular instance, it's called an MQTT gateway. That is going to receive those sensor readings, and it's going to send that data up into a satellite transmitted satellite phone for that purpose. It's going to get up into the cloud through that satellite connection, basically. So you can imagine the transmission issues out in the middle of a desert, and the payload has to be very, very small. So that's why it was developed. So it was developed for speed. It was developed for highly constrained network. It had to be fast, and it's not that new. It was back in the late 90s is when this thing was finalized, and it's continued to morph since then. When you see these new acronyms out there, there's a whole new list of them when you start diving into Internet of Things. Like IPv6, most people have probably heard about that because that affects the web as well. Running out of IP addresses, we need to move to a different version of IP and how many addresses we can have. But when you see 6 LOWPAN, that stands for IP version 6, low power, wireless personal area network. And I know that's a mouthful, but really all it means is that these protocols were made for sensors and smaller amounts of data with smaller payloads. And they also need to be able to be secure as well, because these can be hacked just like any other protocol. So in MQTT's case, it uses an SSL TLS model of security. There's a separate version of MQTT that will run over the UDP, make UDP request, and it has a datagram model for security. So DTLS, if that makes sense. So I know we're getting into a lot of acronyms that a lot of people haven't dived down that deep before, but this this is why understanding the OSI model as a performance engineer is very, very important. So how does that relate to HTTP? MQTT would use the publish and subscribe model. You could actually design it to use request response, but most of the time out of the box, people are going to use publish and subscribe, and that looks like this. You would have a broker. The MQTT broker is the gateway. A very popular one online is an open source broker called Mosquito, and you can have publishers who subscribe to a topic and subscribers who subscribe to the topic. So just think of a magazine. A magazine publishes information, and then a subscriber subscribes to the magazine to get the information. And so the broker holds all these topics with all of these things that have been published. Certain times they expire. You can have multiple publishers that connect to a topic, and you can have multiple subscribers that subscribe to that topic. So that's how the response and request are different. HTTP, we're going to talk about request response next, but that's how it's different from HTTP. It was designed for high volume, low bandwidth, low energy. It is event-oriented, which means it doesn't have to run all the time, which means it can save battery time. So when you see this polling word, that means we're avoiding battery drain there, and we only need to turn on when we need to transmit or receive information from a sensor perspective. Now let's talk a little bit about COAP. COAP could be thought of as like the cousin of HTTP and a little cousin. It's different from HTTP in that it goes over datagrams instead of TCP. It doesn't need an acknowledgement, but very much like HTTP, it has sort of a verb system. Like in HTTP, you have a get and you have a post. Have something very similar in COAP for that. So there's 4 main verbs that you'll see, and we'll actually show that in our demo, how that actually works at a low level. But it's very much like HTTP, but it's basically taken out and stripped down the things that you wouldn't need for that. This is how this would look. Very similar to MQTT, and in these cases, the sensors themselves are the servers. What we traditionally think of as the servers that are sitting on the back end are actually the clients of those sensors. So there's a little bit of a paradigm that goes on there that you have to kind of switch your thinking. But you can have these very constrained environments going over sometimes miles where there's a sensor on a light pole every so many, like a mile down the street. And eventually it communicates to, in this sense, we would call it a gateway, because that gateway's purpose in COAP is to simply translate the COAP data and convert it into an HTTP request that goes into the back end. It runs across the wire as binary, and that's how it kind of it speeds it up because it turns it back into a 0 and 1 versus HTTP, which would be a clear text request that you can actually see the HTML, that comes through. So it's in text. HTTP version 2 is actually more like COAP because it is also binary, one single binary stream and connection. It's asynchronous. It's very much like a RESTful call in an API call. And the verbs that we were talking about, get, post, push, and delete, very simple. It supports MIME types. It has header responses, like when you have an HTTP request that's good, it's a status 200. They have those type of requests that you can view, so you can know when something's not found or when there's something that's been overloaded, like the gateway. And we refer to a gateway in COAP as a proxy because that's what it's doing, is translating that and converting all of those requests to traditional HTTP calls. Currently, there is a handful of tools that support both of these protocols. On the open source side, I love this name, Malaria, is a way to test the Mosquito MQTT broker. There's also some command line tools called MQTT Box, MQTT Spy. JMeter has plugins for both MQTT and COAP. And on the commercial side, Neoload has supported it since 5.3. SmartBears toolset have supported it for, I think, over about 3 years. StormRunner began supporting it through an API that they have written where you can pretty much customize whatever call that you want. And beginning with LoadRunner and Performance Center version 12.55, they also began to support MQTT. And our company, TransactIQ or Endpoint IoT, we created the COAP protocol and released it in cadence with Micro Focus when they released 12.55 last August. There's also something that I would like to mention. There are some plugins to the browser. One in particular, and you'll see this in the demo I'm about to play, is the Firefox add-in for COAP called Copper. By downloading that, you can actually mimic the COAP proxy in your browser so that you can do testing that way. And I'm going to show you a live website where after you see this demo, you can actually do your own COAP and MQTT, just small tests on a live system so you can see what it's like to actually test this. Okay, so let's go ahead and start this demo. Give me just a second to switch over to this. And let's see if this works. I think that might be, this is it right here. Okay. So if you can, blow up your screen so that you can see this larger screen with me. This is the location on the Micro Focus site where you can download that protocol. It's the COAP add-in. It is free. It supports version 12.55 and above. It's available now. I would recommend this Copper add-in from Firefox that allows you to actually see it yourself manually before you actually kind of run any test. And that's available for Firefox. Let's see what version. Yeah, version 55 is what we were using in this case. Okay, so this is the location for this site that I was referring to. It's called Test the IoT. And if you use the COAP plugin Copper to go to testtheiot.com, and instead of using HTTP, use COAP in the front of it, you'll actually see and discover our testtheiot.com site, which supports both COAP and MQTT testing. It's not made for large-scale load testing. It's just made for you to test out something instead of on some production site. So this has a library that is part of the default COAP protocol for testing. Different, you might think of them as subdirectories. They would be like sensors, if you will, that are reporting back information. In this case, you can see we're reporting back a 5-digit number with this request as the payload, and we have these verbs that we can use to test get, post, put, and delete. And this is exactly what our COAP protocol that fits inside of LoadRunner and VUGen actually does as well. So this is just a manual way for you to see it in your browser. And again, it's using the COAP protocol to make the request on a different port, 5683, instead of traditional port 80. So if you have any firewalls that might block that, you might want to consider that. So let's look at that in VUGen. We've already downloaded and installed the COAP protocol from the site, and we've installed it according to the directions. And when we launch a COAP script, you'll see that it's not a record and replay. It is a template script, and it's actually because you don't need to record and replay. It's very simple, so you wouldn't need to record a site. So you can either code this from scratch with just opening up the script itself, or we've already got some hard-coded stuff in there that's commented out, and you can basically look through our code and replace any of the values and just tweak that code yourself. You'll see there's nothing in the init section and there's nothing in the end section. Everything is in the action section itself. So if you're familiar with the API inside of VUGen, you're going to recognize some of the names of these functions that we have because we tried to mimic the web functions as close as possible. So what we're going to do right now is we're going to go through this script, and we're just going to uncomment out what we think we might use. We're just going to make a simple request here. First thing we're going to do is we're going to set some options. These are the same options you might set manually in VueGen from the GUI. We're doing it programmatically. We're setting up a variable called int property, and we're going to uncomment out the COAP reg save param. So we're going to dynamically correlate and grab correlation data, very much how we would do a web reg save param in the web protocol. In this case, we want to capture this 5-digit number that's coming from this site, Test the IoT. So we're going to change the left boundary and right boundary to search through the response that we're getting back from the server, find that number that's between that left and right boundary, and save that off as a variable called test param. Now what we're doing is we're putting a start and an end transaction around a GET request called COAP_request. That's the API call. So what we've got to do now is take out the static host name that we put in there and replace it with a parameter that matches our server name. So we could have just typed in testtheiot.com, but we just wanted to illustrate that if you had different environments, a test website, and then a real website, you could create a parameter just like you can with the web. That could be an IP address, and we're going to put in the testtheiot.com as the parameter value, rename the parameter, and now we're going to replace all of the instances where we have host name with this new parameter name. And we also want to change the end of the URL string from large to what we actually want to request. So we're going to change that to something called, it's a folder called test. And we have a hard-coded message ID that was part of our commented out code. We also want to replace that as a parameter too. And probably you're not going to want to use this same exact parameter type. We chose iteration number and made sure that it was 5 digits by making sure we had enough leading zeros so that we could just run this in VueGen as many times as we want. You're probably going to want to come up with a unique number or a correlated value or something of that nature that you're going to want to send. But you have to have a unique message ID. So we chose to turn that into a parameter, and we only need to replace that particular instance. And finally, what we're going to do is we're going to go down to the bottom of our script, and we're going to uncomment out this command called COAP get int property. The COAP get int property does something very similar to the web get int property, which is, in this case, an argument that looks at the payload size that comes back and makes sure that it's the right size. If we got a very small payload, it might mean that the payload was a failure. And if we want larger, more realistic sizes, then that's sort of like our verification check that this payload was good. So we want to turn on detailed logging. We want to play this in our script and make sure that we're actually getting what we expected. And as you can see in here, we can see everything that happened. We can see all of our parameter substitutions, and we have full log that would come back from that COAP proxy. So we can see that GET request that we chose is returning back 1 in the parameter called test param. We can see that the payload size is 58 bytes. So if I were running a real test, I would then validate that size and figure out if that was a pass or a fail. And then I could fail certain transactions based upon their size if I wanted to. So now let's go in and look at what MQTT looks like. So this is something that you would get standard with LoadRunner 12.55 or Performance Center 12.55. Very similar implementation. It's a template script with code that's already got some hard-coded stuff in there. You can comment out what you want to use. It has both the publisher and the subscriber logic in there. In this case, they do have stuff in the init in the end. So the init section, we're basically just going to comment out the command that connects to a specific MQTT broker. In this case, in testtheiot.com, we've got the Mosquito broker running already. And because it's a different port than COAP, we can have both of these running on our site parallel. In the last step of our script, after it's done running all these action files over and over again, we're going to uncomment out the step to unsubscribe from the topic and disconnect from the MQTT broker. So we're just going to replace that hard-coded value. And then we're going to go into the action section and just take out the comments for what we actually want to do. And in this case, we're going to comment out the uncomment the publish. So we're going to publish to a specific topic with a specific payload. So we're going to publish to the topic called example topic, and our payload is going to be our iteration number and just some other small information. So this is a publisher just over and over as it runs this action file over and over in the controller. It's going to place this information in that folder or queue, if you will, which then subscribers are going to go and look for that information every time there's a change. So here we're actually putting some literal text, vuser, colon, and then we're going to change that to a parameter so that we change the number every time. And it's going to be based on the parameter type called the vuser ID. So if you were running this in the controller, whatever virtual user is in the number that's in your group, that's what's going to be transmitted in this payload. And also whatever iteration number it's on. If you've got this set to run 100 times in a row during your test, it will count that up. And so each payload is going to be unique for this publish command. And then what we would do is just simply test this out. We're going to make sure that we've got logging turned on for this. Also, I wanted to note that there is a monitor inside of the controller for MQTT. There is not a specific monitor for COAP. You could create your own custom ones with some function calls in VUGen. But MQTT was developed by R&D at Micro Focus. COAP was developed by us. But at this point, Micro Focus will take over the development of that protocol and extend it further in newer versions. So we've got our logging turned on. We can see that we're sending the information to that. We can run this and test this as many times as you want in VUGen. And at this point, I've run out of time. I can't get into the controller part, but there are some videos on our YouTube channel that will take you into the controller section and show you test running. There's test results and analysis that you can also look at. We've got some blog articles out there that even go into more detail. And so I'm going to minimize my screen again, if I can figure out how to do that. And I had one other slide here that I wanted to show, which was based on what we've seen as far as best practices. Basically, it just means try to take a holistic approach and figure out how you're going to mimic not only the sensor call, but the gateway itself. Get a great understanding of how that communication and those protocols work, and then start looking at things like network virtualization and service virtualization to fill in any gaps and that type of thing. So if there are any other questions, I'm available to answer any of these. I see some that are on there, but I'm going to turn this back over to you, Chris, and let you take it from here. But thank you very much for your time.
Thanks, Scott. Thanks for that amazing presentation, kind of giving us a deep dive into IoT, a couple of the protocols, and I feel like this is just going to explode the landscape of everything that is really performance and functional for all of us out there in the software and other testing communities. I hope everybody got as much out of it as I did, and now I have to figure out how to present after having that mind full of stuff to go through. But thank you again, Scott. That's awesome. We're going to quick dive into the topic I had for you folks. That is being able to use Splunk for performance analysis. Now, since we are, a big majority of us here, I imagine, are familiar with LoadRunner, the inner workings of LoadRunner, the controller analysis, and VUGen, I'm going to focus more on the results piece. So a couple topics I'm going to dive into here are a brief look at Splunk, the way in which performance tests bring data in, looking at the results, and then also dashboarding. Now, I should point out that in the case here, Splunk is a utility that we use at Independent Health. It is not saying that it is the only tool available. This would really be replaceable with, I have my performance data, I want to integrate it with our enterprise log monitoring and analysis, big data, like an Elasticsearch or other things as well. This just happens to be the one here. So what is Splunk? The definition is up on the screen. I'm not a big read the slides type of person, but the one thing I want to focus on is it a way to collect and analyze? Like I said, here this is what we use. It is not the only thing that is available out there. So this is my example that I'm showing, but I'd like to have everyone kind of consider going a little outside of the box of LoadRunner and integrating in with your practices in your company and really show some of the key advantages you can get out of that. So a brief introduction to Splunk itself. So you have a whole bunch of servers. Some of those servers have applications on them, and those applications generate logs. So those might be web, it might be services, it might be a specific WebLogic server that's the back end to some client desktop type server system, a custom thing, really anything, maybe an IoT device. Then let's introduce Splunk. So Splunk is a way to take those logs, in the common cases, using an agent that will sit on the server itself, analyze the logs, and ship the logs to Splunk. Other ways that it can happen is if you've integrated your app into Splunk. So option one is, I have a server, it has logs. I don't want to or cannot alter the application, so you can put an agent on the server, ship them off. Another option is, I am an application owner and I wish to integrate in something with that. You can do real-time posts to Splunk itself. A couple of fast benefits that we get out of this, and these pictures I know aren't super clear. I promise there'll be some better ones shortly. Are the ability to have our application events go into a tool set which has the ability to query and also create all sorts of really nifty dashboards. These slides will be available after the fact as well as the video. So I want to put up a couple of helpful links that I found, such as overall documentation, what can Splunk monitor, what do you want to do, different sources, how to create charts. You really have a great library out there. So from performance, what do we do for performance here? We do project-specific performance requests, so integrating with the project to ensure that the project meets their SLAs, can handle the appropriate load expected, etc. We do also daily test runs in our one main test environment that mimics production. And in our tests, whether they're project-specific or specifically the dailies, we test a handful of applications, and in that suite of application tests, we have dozens and dozens of tests and results to manage. And one thing that we don't like to deal with is we don't like to deal with Excel reports. They kind of get muddled, they kind of get messy, and let's face it, the audiences we go to don't necessarily have the analysis tool available to them to get all those charts, and some of those charts can be cumbersome. They can't integrate in with your applications and such. So we want to nix that. That's the reasoning that we went this route. So I want to show you how Splunk fits into our landscape. So we showed this picture before of our servers sending data to Splunk. And where does LoadRunner fit into that? So we have LoadRunner. With LoadRunner, you have a controller. You have analysis. Analysis has a database associated with it where all the results go. So we've tapped into that, and we've created a log file out of the database. I'll show you how that works in a moment. And then we ship that log file to Splunk with an agent. This isn't saying that LoadRunner is the one and only tool that can do this. This is just the example using. If you had a mixed mode environment where you had a couple of other tools running along with LoadRunner, they could all do the same thing. This is another really great reason that you might want to use a tool like this, because you can integrate different tool sets worth of results into one place. So being able to make the logs from LoadRunner Go, we have to configure LoadRunner, the analysis tool, to use SQLite as a database. That's not the default, but it is easy to change. You have to create a default template for analysis, and then you have to set up the controller to auto-collate your results. From an execution standpoint, we run the controller via a batch, completing the command line options. We invoke SQLite, and we create a log file, and that log file is written into a location where our Splunk agent consumes that data. So real quick, from a tools perspective, we use SQLite in the analysis tools option, and under analysis tools and template, we create a default template. I think all you have to do is just go there and click default template. Not going to read all these batch files, but just to give an idea, full transparency in what we're doing. Here's an example of the batch file that we use to kick things off, which shows some of the options after the fact for doing the auto analysis, for running the test, and then kicking off SQLite. I should mention it also requires having SQLite installed on the machine, but I do not believe that is of any cost. The SQLite batch file itself for getting the data into the particular format, and then the lovely query itself, which I'm sure you can barely read even in full screen mode. And if anybody wants some details on this, they can feel free to reach out to me later. No real secrets in here, just a matter of formulating our results in the way that we wish to see them. And this is an example of the log file, but don't worry about reading this. I have for you here, digging into the data itself. So for the data, we need to have our scenario and script information, including any transactions and sub-transactions, our timing statuses, because those are, of course, important to us, and any other metadata that we wish to bring along for analysis. So what that might look like here is we have a timestamp, so that we can have things in a trending fashion, what our application name is, the environment name, script, transaction name, and a lot of this detail should look rather familiar to you if you're used to looking at the raw data that's involved from the results of a performance test in LoadRunner. And here's an example of it in Splunk itself, broken down. So a couple prereqs before we look at a demo of seeing our data in Splunk. These are things that we thought of, some in the beginning, some lessons learned, so I figured I'd share them with you. So again, in this example, this is just what we chose. It's already the enterprise tool that we had in available to us. As you look through the demo, you might say, hey, we have a tool like that. Doesn't mean you couldn't use another tool. You should have some kind of an idea of what kind of amount of data you're going to be sending off, because that's going to help you set up the necessary index and sources in Splunk so that it can consume your data. Splunk specific will auto roll off data outside of the size. So if you allocate 500 meg of space to your index, it keeps the most current 500 meg. So just a thought there. And then really think through what you want your data to look like, because it's more important to take the time and think about it before you get the data there, to realize that at some point in time you have data that's no longer useful to you. You want to make sure you get all those thoughts up front. Quite handy. So let's take a moment and look at Splunk. I've prepared a video for you, and let's check it out. So here is Splunk. It is a web accessible application. And the first thing that we're going to do is I'm going to show you a really important page that was helpful to me. I didn't really understand how to query Splunk in the beginning, but they have this great article out there. So if Splunk is something you have or consider using, this is a great article to take already SQL skills that you probably have and to translate them over to, well, what does that mean in Splunk? I want to look for my data, but I don't know how to tell Splunk to do that. This was a really great article that helped me out. And as you can see, there's all kinds of different commands in here that you're used to from querying. So we set up our index. First thing I'm going to do is choose a date for, say, last Friday, just because I want to keep the results set small so that we can focus on what it's doing and not get overwhelmed with an immense amount of data. So I'm going to look at a 1-hour test that ran last Friday. And I'm going to go in and type in our source type. So we have a source type of load runner. This allows us to key in on all the data that we have contributed for performance testing. So it's going to run the search based on that time frame. And here are all the different events. An event is just an entry in the log. And if we take a look at one of these, we can see all the different data elements that we talked about earlier on that were contributed into Splunk. So we have our application name, transaction name, different transaction data pieces such as the status, the amount of time it took for our response data, the start time and end time. And those are all fantastic pieces of data because we can correlate those not only with load runner data, but also with other application logs that are coming to this system. So we can continue to drill into here. So I'm going to take the web, for example, and just drill into the web. And as I click and interact with Splunk, it will continue to mature my query for the use of our analysis that we're doing. And we can see that it's breaking things down for the web. Now I want to take for a moment and I want to do some actual analysis of the data. So if you had this raw data in Excel, you'd probably want to calculate some averages across a particular time. So we're going to do just that here. So we're going to look at the average response time for our web application. And it's going to run, it's going to calculate from all the events that happened during that time and date range. And it's going to give us an answer. Now this answer is actually across the entire application, which may not be that useful to us, so we can keep narrowing this down a little bit more. So I'm going to tell it to do it by our script. And if we do it by the script, you're going to see all the individual scripts and the response times. And what's nice is this is like throwing all of your response data into a database that you can easily query. So another statistic we might want is we might want to know what our peaks were for each script. So we're going to run those, see what our peaks were, and we can see all the averages and peaks. And there's probably countless calculations that you could do. Now what we can do with this that we can't do with traditional databases, I can do some visualization. And let's face it, a picture tells a far better story to our individuals that we're working with, whether it be the business or other technical folk. It's a lot easier to get some details out of it. We can look at things in a variety of different standard formats, bar charts, line graphs. If a pie chart was acceptable, that would be available as well. And I can also take and maybe split out a chart, just some really handy things that you can do with a tool like this, because it may be beneficial to you to make it so you can call out our peaks and valleys a little bit better. So here I'm going to split it off so that we can see on a separate access our max response times. And now notice that our averages don't get lost if there's any tremendous peaks. You know, we want to be able to produce what is the best picture available for us. Another thing that we can do with this here, just a moment. Oh, I forgot to mention that you can also see the data below, so you get the raw data available with your charts as well. Another thing we might want to do is we might want to look at some trending data as well. So I'm going to just key in on one transaction itself, and we can see all the events for that transaction easily brought through. Let's look at some trending data doing a time chart. A time chart is the ability to take all the events and chart them based on whatever span we want. Here I think it auto defaults to about a minute. So you can do it by day, by week, by month, depending on what your date range is as well. And as I said, this is just a really great way for us to be able to quickly get in and look at data. So I'm going to go and select all of last week, and we can see it all charted out. And here it defaults to a day. And let's change that a little bit, and let's add in some peaks as well. So you can see across the day, every day last week, what our different peaks were. So we can show that as well, and just really paint a really clear picture as to what's there. Now, if we want these pictures to be reusable, we can create dashboards within Splunk that allow us to reuse that data itself. Then in essence of time, I'm just going to show the dashboard, and you can do all kinds of really fun tricks and techniques with it. You can add time pickers, you can add other types of things. So note here that we could add time pickers and other things to make it so there's an interactive chart. So you actually can make a self-service, I guess you could say, portal for your consumers or for yourself to use in order to create really great visuals for folks. So I'm going to show a couple of dashboards just to give an idea of what we can do. We can do really great trending. So I think this is a 6-month view. I really don't, unfortunately, won't be able to see there, but I believe this is like a 3 or 6 month view of our averages in the blue, our peaks in the yellow, and my gosh, I don't remember. I think there's a standard deviation in the red. I should have made that a little clearer. I apologize. You can do all kinds of trending with it, a lot of real-time data. We can do some comparisons. So this chart on the left here is a before and after. So maybe before a particular release and after the release where a change is made to the environment, and you can do trending that way. You can do volume and response comparisons. So you can compare your production and your pre-production to understand how close you're representing and simulating your traffic. If you don't have, key requirements, or maybe you want to double check your requirements. They told us we're only expecting 1,000 users a day. Production shows 5,000 users. You can do a lot of really great comparisons there. And what's great is we're able to combine the performance data as well as the really any data that's in your system in one environment. Here's a really great one that I like to look at, and that's the ability to take and chart out your sub-transactions. So the charts in the blue in the first row across is going to be the overall response times, and then the charts below are going to be then broken down into individual pieces and components. That's pretty much it that I had prepared on using a tool like Splunk for doing data analysis of your performance tests. Before we jump into Q&A, I wanted to just mention we have a couple of really great upcoming webinars. Actually, tomorrow is Build an Efficient Security Ops Center with ArcSight, and then on the 28th, really unlocking your ALM investment with ALM and ALM Octane. So now I think we have time for probably 2 or 3 questions, quick, from our Q&A, and I believe we will be looking at the other questions and then replying back in either a blog post or in a or individually to you. So before I mention at the end of this, there will be a short survey. Please fill it out so we can figure out how to present better to you and just learn from you as a community. So I'm going to grab 2 questions here. So one question is, Splunk needs to be executed with full log or only when logs appear. No issue with I believe that's saying with a load generator crash. So the method that we chose to use right now, if something goes wrong during a test, we may lose our results. That is true. We could integrate, as you recall, the HTTP post. We could integrate HTTP post into all of our scripts. We have not yet gotten any details on that at the moment. It's pretty much an investment that we haven't planned to make at this time, but you could do that. I believe there are also techniques that if you crash, there are some occurrences where you can get a partial result and you would have to manually compile that for analysis. Another question I see is, you could also do mapping of Splunk graphs to the Performance Center run. I'll be honest, I'm not a Performance Center user, haven't really used it much, so I don't know how to properly answer that. But we could always have someone get back to you guys on that to figure out how those integrate. Scott, I think maybe one last question. There's a question here about MQTT protocol differing from HTTP protocol. Do you have a moment to mention some of the, maybe 1 or two differences of the two?
Yeah, we talked about this in the presentation, but it's worth mentioning again. MQTT has more of a publish and subscribe method, whereas HTTP has a request and a response. MQTT does run over TCP, but it's made for smaller payloads than HTTP, and it runs on different ports, and it's pretty much stripped down from what you would get out of HTTP. There's not as many verbs available.
Awesome. Thank you very much. I do believe that's probably all the time that we have for questions at this moment. We will take any additional questions and either touch upon them in a follow-up blog post or reach out to folks directly. And as mentioned, Scott has his information in the deck on how to reach out, and feel free to reach to me in really any form that you find for me, through LinkedIn, through Vivid itself, or others. We would like to always help and share. So I really hope you found this presentation to be beneficial, learning about performance testing considerations and techniques for IoT, as well as thoughts for going and using your performance data in analysis tools such as Splunk. So thank you all for attending. Don't forget about the short survey afterwards. I really appreciate your support in the Vivid community. Thank you. Have a great afternoon.
The